Good morning, everyone. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT and Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID-19, we wish everyone and their families a safe time and we all will together pass this soon. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers will publish in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of knowledgeful and interactive sessions. I would like to welcome you to the technical session number 4 and further introduce you all to the chair for this session, Professor Dharm Singh Jat. Professor Dharm Singh Jat received his degree, Master of Engineering and PhD in Computer Science and Engineering from prestigious universities in India. He is a professor of computer science and Namibia University of Science and Technology. He is the author of more than 150 peer-reviewed articles and the author of editor of more than 20 books. His interests span the areas of multimedia communications, wireless technologies, mobile communication systems, edge roof computing, and software-defined networks, network security, Internet of Things. He has given several guest lectures, invited talk at various prestigious conferences. He has been the recipient of more than 19 prestigious awards, such as Eminent Scientist Award, Distinguished Academic Achievement, Eminent Engineering Personality, CSI Chapter Patron, CSI Significant Contribution, Best Faculty Researcher, Best Faculty Staff, Technical Staff, Outstanding University Service Award, and Distinguished ACM Speaker Award. I would like to welcome Professor Dharm Singh Jat. And now we will move to...
I will request Dr. Dharam Singh to just give up an opening remarks.
Yeah.
The session starts.
Thank you, Basil. Thank you, Amis, for giving me this opportunity. So, in addition to, because I see in this session we have 9 papers related to the big data security and the computing parts. So, just I want to share with the students that we are going to establish a UNESCO chair in smart and secure communications, in which we will be strengthening the smart communication, big data infrastructure, as well as the cyber security. So now I think the international community will have to strengthen the UNESCO chair regarding these 3 domains, and I can see some of papers are all of the papers are very, very important. You know, you have only you have 15 minutes, 20 minutes for the 12 minutes for the presentation, and 33 minutes for the question answer. So I think now Basil will guide you to start your sessions now. Thank you.
Thank you, Professor. Okay. The first presenter is Salver Softic, presenting Towards Empowering Business Process Redesign with Sentiment Analysis. The floor is yours. You have 12 minutes to present, and I'll notify you on the 10th that you have 2 minutes remaining.
Thank you. So let me just start my slides. Can you see my slides right now or not?
Yeah, that is fine.
Okay, so do you see the started presentation or just the slides?
Yes, we can see the slides. You can begin.
Okay, good, good. So, well, it's a pleasure to be here today and share the experience at this virtual event. The paper I want to present is about empowering business processes redesign with sentiment analysis. My name is Salvar Softić, coming from the campus University of Applied Sciences from Graz, Austria. My colleague and myself, we made some talks about business process redesign as a part of the business process lifecycle, and taught how all of the stakeholders that are involved can be supported by AI, in particular with the sentiment analysis, to make a better design of the processes and to improve the process design overall. So to the agenda. Can you see the agenda right now? So I just move to the I will talk about motivation, the problem we saw tackled actually with our paper, and we show the preliminary solution and some results that we did using the sentiment analysis that we involved into in particular into the redesign of the business processes. And at the end, I will just give some reflection, draw some conclusions on the achieved, and talk a bit about the next steps. In particular, motivation is actually the business processes and the traditional business process management. Most of the business processes I actually management and life cycle is done from top down. So we have a top down decomposition approach within the life cycle. And this is usually long-running improvement process. So we have a lot of stakeholders, a lot of steps in between. This requires also intensive negotiation that need to be also syndicated, and then be also coordinated some way to achieve the change in the life cycle, also in the processes and the models of the processes. So our motivation actually was to change a little bit the traditional process and to involve all the stakeholders and to use the benefits of AI in some form to integrate all of this into this process that we have, which is the business process lifecycle, very well known from the literature. So what we do actually, we support the so to say egalitarianism, so the equality of all of the stakeholders and their opinions. So we don't make no differences between the customer, stakeholder, or process performer, or some other role. And we and as we say, since our focus is on the first two steps of the business process lifecycle, which is the process analysis and process redesign. So we are in the field actually here of the social information system, and we just made some research, basic research, and found that there are already some works like the one that I'm referencing down there, which is the business process knowledge framework. And we used actually the role from this paper to involve into the improvement of the business process as considering them as a different roles that are participating in the process redesign. So based on this, we just made like a prototype of a tool which actually does a very basic thing. So we have like the process as is, and we want to bring it to the form as it should be. But all of this knowledge is actually in the heads of the participants from the perspective that should be taken into consideration regarding the special roles I mentioned. So we have the special roles on the left, superior decision makers, customers.
I'm sorry to interrupt, but the slides are not advancing.
I'm not advancing. Okay, so so this is actually what I asked at the beginning. So to be sure that to see whether everything. So do you see now? Are the slides advancing now? You see them changing or not?
Yes.
Okay.
They are.
So you see actually my reference screen. So that's the problem. But regarding the time slot, I will not change the view now. So I thought about the motivation. Then I said there is like a business process life cycle. And we, as we said, we want to support the equality of the participants. And those are the different roles we identified for the research. So and now we are here right now. I'll make it a little bit bigger. And actually what we want to do, we want to bring the process from as is as it should be. And in between, we just offer to the different participants the possibility to comment the different tasks out of their perspective. And we just use the sentiment analysis to score their opinions to be rather positive or negative. That's the main idea between the software that we implement. So that's the also basic idea between the Senti-Promo tool. So method of use, first we import as is process. Second, the stakeholders insert their personal opinions to the process tasks. Then we calculate the sentiment scores. And finally, the analysts use them to redesign or redraw the process. And then it's again offered to the discussion round. So that's the basic idea behind of this. So, and a little bit to the conceptual architecture. So we have a 3-layer application. The most important levels modules are actually the task level comment parts. We also have like a repository for the processes that is searchable, and we have also modular and where we can redraw all these parts of the processes, and they are all drew in a form of BPMN, which is like a standard for process design, and is supported by many tools actually. And those are stored actually in the database, the comments and the values, and we use them actually as a reference for improvement of the design. So a little bit to the sentiment score, sentiment analysis module. So what we did actually, we used as test data Twitter airline sentiment, because we use the process of the check-in at the airport, because we have a case study with a South American air company. So this is the reason why we use it as a case study. And we use the test data that we as test data. We use the Twitter airline sentiment from the Kaggle platform, which is like a public data set, and also the training data sets from the different American universities, or most famous Twitter sentiment data set, reference data set, which is a sentiment 140. And for the training, we had about 650,000 tweets and reviews from Amazon, EMDB, Yelp, and Twitter. And yeah, so we tried different algorithms, and the best one that it turned to work quite good. Our criteria was actually just basic, which is the area under the curve, and the best one that we that achieved the best results, actually considering our needs, which are quite basic, was the averaged perceptron binary, which is a very a simple form actually of neural network. And when we evaluated all this data, so it turned out that we have a quite encouraging, I would say, encouraging sensitivity, specificity, accuracy, and F-score. And this is the confusion matrix. You can see how much true, positive, negative are there. So for the test data, we used about 11,549 tweets from airline company services, where all the customers complain about this service process within for a particular airplane company. So it was like testing and training, and then when we run it, so the tool looks like this. On the left, you have like a preview, and then you have the process that this one is a very simple process actually of so let's see, enlarge it a little bit, of entering the terminal, dropping off the bags, or making the check-in all this by the self-service or by the counter desk, yeah, and just proceeding to the security check. So it's a very basic process actually what we use to evaluate, and what we can do actually, you can add some tasks, and the sentiments, of course, is after you just write your opinion out of the perspective of one role, like customer or superior, decision maker or process performer, whatever. So the sentiment score is calculated, and what we have at the end, actually, it's like a list of all opinions on the process tasks out of the different perspectives and roles. And we also measure like an overall sentiment score, and we also measure like a sentiment score per each role. So just to distinguish, to say maybe the customer made the more remarks which are more negative actually to the process as the people who run the process. So to make this to distinguish these aspects. So so that's pretty much it what this tool can do. So you can like you have like a checklist for the improvement, for the redesign of the process that the analysts become, then draw the process again, and maybe make some split some steps in different steps or more steps to be more clear process, and to enlarge the visibility and transparency of the project, and also improve the process as well. So finishing, I can say that what we mentioned, at least with this company, with the first workshop that we did, that it really helps at least to prioritize, to make the priority between the tasks that should be think about between the tasks which are and to find like a bottlenecks and the problems where the people have complaints about the service offered. This is why this visual approach is quite good. Also, the sentiment and the scoring of the sentiment allows us a little bit to rank the problems and rank them against the sentiment score. The accuracy about 80% is quite good, but we'll try out it with different data sets to achieve a little bit more, to be more applicable for the other processes. And we also want to make a web version. This is a desktop version, and want to maybe make some connectors to the social media networks in order to make it more feasible. Also for the people who are not, you know, they don't have to install the desktop application everywhere. So it should be like a there should be a seamless approach possible for this tool. And considering the pandemic and everything what's happening, this airline want to also the redesign their processes, and this is what we're gonna do in the future, and to make a little bit more intensive case study in this area. So I hope I could hold the foreseen time for this presentation. So from my side, I'm finished. So if there are any questions, I will be more than glad to answer them.
Okay, thank you for your presentation. You have 3 minutes for questions. Any questions?
It seems like nobody wants to ask the question. So, anyway, yeah.
I'll wait 1 minute if anybody wants to ask any
Yeah.
question.
Okay. So I don't know. It should be. So maybe I can tell somebody's interested. So there is a like a Google site. The name of the tool is Sentipromo, so you can download it. And yes, if you're interested, so there is also some contact data. So you are more than glad to contact us also per email if somebody is interested to get more details on this project that we are running right now.
Yes, thank you. Thank you. So if nobody has any questions, we're going to move to our next presenter.
Thank you very much.
Thank you. Our next presenter is Takumi Kobayashi, presenting a generalization of secure comparison protocol with encrypted output and its efficiency estimation. The floor is yours. You have 12 minutes. I'll notify you on the 10th that you still have 2 minutes remaining.
Okay, thank you, Professor. I'll share my slide. Slide. Okay, can you see my slide?
Yes, we can. You can start.
Yes. Okay, I'm Takumi Kobayashi from Shima University. Today I'd like to talk about secure comparison protocol with encrypted output. At the beginning, I'll show you the agenda. In my presentation, I call a secure comparison protocol, SCP for short. And now I'd like to start with the background of our study. Okay, because of development of ICT devices, opportunity that treat sensitive data increase. However, in the Earth society, problems about information leakage can be a critical problem for many people. For these reasons, privacy preserve techniques are very important. On the other hand, we'd like to obtain useful data by data mining. Yeah. So to solve these concerns, many researchers focused on secure multi-party computation. I call it SMC for short. SMC can deal with private information securely, so it is very useful technique. In particular, SCP is one of SMC, and it is very important factor for many applications, such as secure online auction, secure biometrics, and so on. A classical SCP is SCP under Yale's millionaires problem. Now, I illustrate it as figure 1. Party A and Party B input their private information, private integer each other. At the end of the protocol, Party A outputs the comparison result without leakage of any private information. Again, this SCP is very important factor for applications of SMC. However, some applications treat the comparison result as private information. So now party A and B can get the comparison result. So this SCP is not suitable for this application. For this reason, several researchers focus on SCP with encrypted output, as I illustrated as figure 2. This SCP outputs the ciphertext of the comparison result. Because of this feature, party A and B cannot know the comparison result each other. So this SCP is very suitable for some applications such as secure biometrics and secure statistics. This slide shows previous work. Some researchers proposed SCP with encrypted output. However, many SCP still have efficient problem because the computation proceeds bitwise, 1 bit by 1 bit. So to solve this problem, we focused on SCP proceeds multi-bit by multi-bit. We expected that this SCP can be more efficient than SCP proceeds bitwise. In 2018, we proposed 2 protocols. I call them Cage Protocol 1 and Cage Protocol 2. Cage Protocol 1 proceeds bitwise. On the other hand, Cage Protocol 2 proceeds 2 bit by 2 bits. It was the first step to the generalization. Next, this slide shows the contribution in this paper. The main one is development of the SCP proceeds W bit by W bit for any positive integer W. It is a generalization of Cage Protocol 2 in previous work. And we proved correctness by mathematical induction. And moreover, we estimate it for the computational cost and compare the cost with that of Cage Protocol 1 and 2. Before I explain our protocol, I'd like to talk about a building block. In this paper, we use a barrier encryption scheme. It is very common homomorphic encryption scheme. And this scheme has the following homomorphic property. So in our protocol, we use this property to compute a comparison result using ciphertext. I'd like to explain our protocol, but first of all, I'd like to talk about the overview and some notations to describe the algorithm. Finally, I'll illustrate the algorithm briefly because my presentation time is limited. This slide shows the overview. In table 1, Cage Protocol 2 proceeds 2-bit by 2-bit to compute the comparison result. On the other hand, our protocol is a generalization of Cage Protocol 2, so it proceeds W-bit by W-bit. In the output, these outputs are the same, and I'll skip the computational cost, and I'll show you the later. And before, we briefly proved that our protocol is secure under semi-honest model. Moreover, these protocols need a secure division protocol as sub-protocol. This slide shows the sub-protocol. I illustrated it as figure 3. Party A inputs the ciphertext of integer x and divisor. On the other hand, party B inputs divisor D and secret key. At the end of protocol, party A outputs the ciphertext of division result without leakage of party A's integers x. This slide shows notations to describe the algorithm. We donate a non-negative integer a as follows. This is just binary representation of integer a. And moreover, we represent the integer a as follows. This is 2 to the w's power array representation of integer a. So we use the notation AI because our protocol proceeds W bits by W bits. So AI is equals to 0, 1, blah, 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 or 2 to the w's power minus 1 in this protocol. So we need one more slide for notations. So here, an integer I is greater than or equals to 1 and less than or equals to large H. So for I, Ti stands for the comparison result of the left side integer is less than or equals to the right side one. So for example, if the left side one is less than or equals to the right side integer, then Ti equals 1. Otherwise, Ti equals 0. In addition, note that if I equals T large H, then TH equals the comparison result of that A is less than or equals to B. Okay, now I'll explain the algorithm briefly. Party A and B input the private information each other, a private integer each other. And for initialization, party A encrypts some values. And following 4 steps, 1, 2, 3, 4. In 4 steps, party A and B compute a ciphertext of Ti plus 1 recursively, thereby carrying out iterations from I equals 0 to I equals H minus 1. Because of the randomization, party B cannot know the TI, even if party B decrypts the ciphertext. And at the end of the H iteration, party A has a ciphertext of TH. In other words, party A has a ciphertext of that A is less than or equals to B. So finally, our protocol output next by bit inverse, party A can get the ciphertext of that A is greater than B. And finally, our protocol outputs what they want. This is the overview of the protocol. And finally, I'd like to talk about the computational cost. I illustrate the comparison of the cost as figure 4. A vertical axis means the number of the multiplications in our protocol. Horizontal axis means the number of the W. It is the block size of our protocol. From figure 4, we can see that our protocol is more efficient as W is increased. And our protocol is more efficient than KH protocol 2. Therefore, W is equals to 3 or greater. But it is not more efficient than KH protocol 1. I conclude my presentation. We proposed secure comparison protocol with encrypted alphabet, and it proceeds W bits by W bits for any positive integer W to compute the comparison result. And it is generalization of KH protocol 2 in previous work. The computational cost is more expensive than that of KH protocol 1. It is unfortunate result, but we achieved the generalization and estimated for the computational cost. It is variable result academically, I think so. That's all. Thank you for kind attention.
Thank you for your presentation. Now you have 3 minutes for questions. Any questions?
Hello. Hello.
Yes, Professor, proceed. Yeah.
Yeah, if there is no question from audience side, can I ask a question?
Yes, certainly. Yes.
Thank you, Kobe. One question is your proposed protocol is the proceed W bit by W bit. So what is the optimal size of W bit and what are the limitations with respect to the KH protocol one?
Okay, thank you for your question. Actually, it is a feature work, one of feature work. We have to optimize, we have to find the optical, the block size. And you know, efficiency and security is a relationship. So if we use the large number as W, it is very more efficient, but I cannot claim that that is secure compared to the W is more smaller. So as a feature work, we have to find optical W, and we have to try the security proof for the each numbers.
Thank you, Kobe. Thank you.
Any more questions? Okay, thank you. Now our next presenter is Libero Nigro, presenting performance comparison of two Java-based actor systems. The floor is yours. You have 12 minutes.
I think Professor Negro is not here. So,
oh, okay. He's not here. So
I think he would be joining at the end of the session. If he joins, then we will take him. Otherwise, we'll skip. So we can go ahead with the next presenter. Yeah.
the next presenter is Wang Hu, presenting secure trusted operating system based on microkernel architecture. The floor is yours. You have 12 minutes. I guess Wang is not here as well.
I guess, yes, the same.
So then we move to the next presenter, Sarah 8 Lamalam, presenting towards an ontological approach for the integration of information on operation and maintenance in BIM for road infrastructure. You have 12 minutes to present. The floor is yours.
Sarah is here. Sorry, Basila, I don't think she is also here.
No, I don't think she's here. So we'll move to the next presenter, or
Yes, we will move ahead.
yeah.
Yes.
Okay. So our next presenter is Elisa Monaco, presenting classification of finite groupoids of order 3 by using image patterns. You have 12 minutes to present. The floor is yours.
Elisa again is not here. I don't see her on this meeting.
No, she's not present.
Okay. Is there any last presenter?
Yes, our last presenter is Ivan G. Kamenev, presenting
Yes, she is here.
metric analysis of big data of payment system based on Kolmogorov-Shannon coding methods. The floor is yours. You have 12 minutes.
I'm present, but I need several minutes to start.
Okay, that's okay.
So do you hear me?
Yes, all clear.
Is presentation working?
Yes.
First of all, I want to apologize for my pretty terrible English. I will try to speak as clear as I can, but I fully understand that it is not good enough. Then again, I will try. Our research is, and second starting remark, I will try to skip all the basics, assuming that everyone understands what is data mining, what is big data, what difference is between data mining and machine learning. So if everyone will have any questions about it, I will try to answer, but I will assume that if there is no question, that such basic details are not needed to be speaked about. Our research is about the problem of raw social technical big data mining. The fundamental scientific challenge in this area includes two states for some algorithms, a high clear formulation of the problem, and to give a meaningful interpretation of the identified dependencies. Both require a good understanding of the data structure, the optimization problems to be solved, and the format of the forecast to be formulated. As a result, big data is used actively with mostly technical systems, such as image recognitions, but not for the social problems, not for the social technical systems, such as payment system in our research. So it is pretty hard to, because it is pretty hard to understand the problem clearly, to formulate it, to formulate a pretty formalized problem. We're proposing to use the metric analysis, in particular metric data analysis method, to make such understanding about the data properties. Metric analysis allows us to detect various errors in data.
I'm sorry to interrupt, but your slides are not advancing.
Yes, one moment. And
yeah.
I will also try to.
Did work. Now it's, yeah.
I will also try to use camera, but it may also take one moment.
It's okay, you can carry on.
One moment.
Yeah.
Okay. Okay. So camera should also work now. Metric analysis allows us to detect various errors, form a general idea about the data flow, segment it, and formalize some forecast problems solvable in the future by machine learning methods. The proposed approach is illustrated by an example of the real big data flow, large Russian payment system. You might know or not, but in Russia we have several national payment systems in addition to international. They are quite big, so they have a large part of the market. And this research is made on the basis of one of these payment systems. It reports payments made by people, including a large number of characteristics of the payer, recipient, and the transfer itself. Research questions for this big data are vaguely formalized and constantly change as the payment system develops. Therefore, a meaningful analysis of such big data requires us to use new methods of data analysis. The volume is about 10 in each 8 order of magnitude records annually. So it is pretty hard to explore all the floor. We are interested in these applied problems. Are the payments logged correctly? Is there any data lost or recorded incorrectly? Does the payment system track the user's identity efficiently? Does market department of the payment system use correct interpretation of the big data features? And what factors determine the level of users' activity in the payment system? I will skip most of the questions about the features of big data as a data type and point only that there are several fundamental problems that are not allowing us to use traditional statistic methods. The main problem we try to research in our work is the problem of quantitative analysis of all the statements that we make. It is pretty easy to find some dependencies in data, to find some factors, but it's pretty hard in data mining to state how accurate our opinion is. How sure are we about all the statements we make? The main specific of social data is that there are a lot of characteristics, unlike in technical big data where usually there are 2 or 3 dimensions. In social data we have several dozens of characteristics that we need to analyze. So real multidimensionality and a large number of quality problems in data logging leads to pretty pretty unsure answers, positions about all the problems we research. That's why usually we don't see a lot of research in social big data. Only simplest data mining apparatus is available for such type of data. Our method of metric data analysis allows us to change a lot of these approaches and answer these problems. It is a methodological approach which includes the research of data's topological and the metric properties, the distribution of observations in the metric space of characteristics. This approach is mostly developed in engineering science and in social science is rarely used because of real multidimensionality of the data. Our method tries to mitigate this problem. Let us briefly consider the general logic of the method. Its mathematical basis is the construction of epsilon data nets and coverings introduced by Cloud Shannon for general population of the data flow. Geometrically, this means that the set is approximated by a collection of balls or cubes of appropriate dimensions. The smaller the diameters of balls are, the higher approximation accuracy is. Such metric nets of any set is a subset with a number of points for which it is true that any point of the set lies at the distance of at most epsilon from the subset. Omitting the mathematical details, these methods allow us to obtain not just some net, but net with known characteristics of completeness, precision, and reliability. So we can formulate how accurate are we, how sure are we that this net represents the big data. We can construct net with more or less epsilon depending on what completeness, precision, and reliability we want to have. This method requires a collection of data, selection of relevant characteristic, creation of the multidimensional space, and its analysis. Because big data flow is recorded on several servers usually, and in our particular case, it is not easy to collect the data and to create a big data from the flow. Operation times are brought to a single standard, the time of login on the server, and we made some preparations to make sure that only non-personalized data are used. We create a sample, randomized sample on a scale of 10 in the 6th order of magnitude, which in our calculations is enough to make some statements about the data, not statements about all 17K characteristics at once. So we cannot be sure about all the combinations of payment. But if we speak about 6 or 7 characteristics most relevant for particular questions with this size of sample and with specific methods of approximations, we are sure that they represent general population good enough. We also added some calculated characteristics by using special request to the logs of data.
Sorry to interrupt, but you still have 2 minutes remaining.
Yes. Okay. So then I skip all the details about the method and go into the conclusions and the results. First of all, we found during our research that some combinations of characteristics are not necessary in data. Some can be combined because they in fact are the same classification, just in looks, this classification is divided into 2 or more. Second of all, we found that several large corporate clients strongly desired the metrics, which was which was of a great importance for the commercial purposes, because we find that all that conclusions that commercial department made are based on the average characteristics of data, but we see that in reality only 10% of the metrics are the real clients that are simple people, not the large corporate clients who obviously use specific tariffs and are not relevant for the purposes of usual tariff statement. Then we found some technical errors in data flow. For example, some characteristics that are for some reason unknown for the technical specialists not recorded correctly, while they should be recorded and nobody knows about it in corporation. There are some stories about it which were fixed based on our research. It is pretty easy in our interface to see that some characteristics are not recorded. And we found some trends, some dependencies which we mostly skip in this research course. It is a separate large question, but I want to note that any statements about trends need to be researched not only on the sample, but checked in the big data flow, because the sample is just a sample, and there might be a mistake, sampling mistake, if the flow is not stable. As our flow is not stable, it explodes in the size of transactions. I will then stop my report, and I am ready to answer any questions in particular about method or about the main features of the particular big data flow.
Thank you for your presentation. We have 3 minutes
And
for
I
any
apologize
questions.
for not being fully ready. I was not really expecting to answer this early.
It's okay. It's okay. Is there any questions?
Thank you, Ivan, for your presentation. So the property used the method for metrics data analysis. So how the payment system is secure?
How, what?
Because your mechanism can be identify the error in the system, error in the storage. So if you can find the error, then you can also refix. So how the transition is secure?
So you are asking how we find errors in the data logging, or how we fix it, or something else?
Yeah.
We find the errors by some unexpected features in metrics. For example, if we see the results of metric analysis in the subspace of some characteristics, we see that for one of the characteristics, we don't see records, but we expect them to be here. So we know that some of servers are not logging this information, or they are logging it, but the request to servers are not correct. It is pretty hard to fix such problems because it requires us to ask a lot of technical specialists that administrate the logs what is going on. For example, we find that for one of the interface for one of mobile systems, okay, I probably can even say that it is about Apple platform, that our technical system was not able to identify user. Well, you surely understand that if we are working with Apple, we know the user. So we can say that one person made several transactions, but for some reason, technical system did not log this information. Probably because the technical specialists knew that it is known who is making this transaction, and they did not think about special activities to store this information. Such problems are always found in real big data, because we work with real people and real systems, and we cannot think that everything is made correctly. And if we then
thank you.
state some
Thank
machine
you.
learning tasks, we usually find that task is not calculated correctly because in data there are systematic problems which must be found previously.
Thank you, Ivan.
I think there is one more presenter who is already on the session, Alisa.
Yeah, yes.
There, but again she left the room. I don't know why, but
maybe some network problem.
Yes.
Maybe.
Can you check, Basil, if anyone else is present? Otherwise, we will go for the closing remarks.
Okay, there is no one except for Elisa, but she left the room right now.
More time you can cross check and then we can do it.
Okay, I sincerely thank our authors for their excellent presentation in this session and all our participants for being a part of this International Congress. I hope this session was informative and knowledgeable as well. All the presenters will be getting their digital certificates through mail within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 4 to 6 months. Kindly cooperate with the team of ICICT as and when intimated.
Basil, I think there is one paper from Sarah and she just joined the room. So can we take that paper?
Elisa just got admitted into the room. I guess she will present.
She has a network problem, but there is one more paper.
Hello?
Yeah, Sarah is here. Oh, okay.
Sorry for the inconvenience.
It's okay. Okay, our next presenter is Sarah A. Lamalam, presenting towards an ontological approach for the integration of information on operation and maintenance in BIM for road infrastructure. The floor is yours. You have 12 minutes to present.
Okay, thank you. Can you see my screen?
Yes, we can. Yes.
Yes, we can.
Thank you. Hello, and thank you for this opportunity to present our research work. My name is Sarah H. Lamalam, and I am from Morocco. I am a surveying engineer and a PhD candidate. This presentation entitled Towards an Ontological Approach for the Integration of Information and Operation and Maintenance in BIM for road infrastructure is realized as a part of a research framework to obtain a PhD degree. Our presentation will contain research context first, then we'll present research objectives, the research scope and methodology, then research contribution, and finally, we will submit research progress, current research progress. Please consider that for this presentation, BIM refers to building information modeling and O&M refers to operation and maintenance. Also, numbers between brackets refers to paper references. For research context, building information modeling is a collaborative work process around a 3D digital twin of a building. It grants the intervention of several stakeholders on the same structure model to handle it throughout its life cycle. It enables information availability and accessibility for the OM phase with non-additional efforts. Particularly, and for road infrastructure, the operation and maintenance phase is a part of this facility life cycle. It has a major importance as it secures their sustainability. However, this phase is not satisfactorily integrated into the BIM standard, which is called IFC. After its integration in the building sector, BIM has proven its efficiency for infrastructure as well. It's been increasingly adopted in infrastructure projects for general infrastructures, road infrastructure, bridges, standards for transportation infrastructure, and infrastructure management. However, integrating BIM into road infrastructure projects is still problematic. It's noticed that it is applied outside the standardization context, and it is only concerning design and construction phases. To standardize the BIM, the IFC is an open data standard that enables a trouble-free exchange of information about a structure. The current versions of open BIM standards developed by Building Smart are IFC 2.3 for buildings and IFC 4 for infrastructure facilities. Two other research projects are in progress: IFC Bridge, that describes specific objects for bridge structures, and IFC Road for objects related to road. Despite the integration of BIM in the road infrastructure sector, there is no official IFC version that describes specific objects for roads. In fact, the IFC road presented here is still under development. As a synthesis, issues for integration of BIM into road infrastructures are: first, the development of IFC standard, which determines the data structure for road infrastructure, is still in progress. And second, the use of BIM in scientific research works outside the context of standardization is often applied in the design and construction phases and remains minimal concerning the operation and maintenance one. These issues are related to, in one hand, the high complexity of road infrastructure projects, and in the other hand, to the high amount of information to manage in operation and maintenance phase, which is an exceptionally long and costly phase. In this operation and maintenance, if the information of operation and maintenance are integrated into BIM, they will be available and accessible to all stakeholders of a facility project. So this integration will decrease the time and cost of the operation and maintenance phase considerably. To do so, studies conducted in the scientific and industrial field can be classified as follows. First, procedures for mapping BIM to GIS-based facility management system. Using classification for data transfer to link a classified BIM model with an asset management system, or using BIM models to visualize the OM content of a database, or finally developing an OM taxonomy linked to object of a BIM model. For the standardization context, several international efforts have been made to define the information requirements that a facility management system must fulfill for the operation phase. These initiatives are the ISO 55000 standard, the PIS 1192-3 standard published by the British Standards Institution, the OROTL standard, the Building Smart Technical Report on the requirements of infrastructure manager in a BIM process. We are not going to detail these norms since they are already detailed in our paper, but we are going to say that the challenge is that these standards and norms are even all-inclusive for all infrastructure or general for transport infrastructure, or include requirements for the whole investment phase of a facility life cycle. So they are not particular to road infrastructures. To resolve integrating operation and maintenance information in road infrastructure BIM, our research aims to first study operation and maintenance information requirements for road infrastructure, study IFC schema content for OM information, and finally propose an ontological approach called IFC Infra for OM to integrate these requirements within the IFC schema. To do so, the ontological approach proposed in the paper concerns two knowledge domains. The first one is the operation and maintenance domain that will include international standards, scientific research work, IFC OM content, and official technical documents for specialized organizations. And the second domain is the BIM for infrastructure domain. The scope is related to the integration of information from the first domain within the concept of the second to have a road infrastructure BIM. For the research methodology, it contains 4 steps. The first one, concern literature review. It aims to extract O&M relevant information in the IFC standard, analyze international standards relating to the OM phase, study the literature review for research work, and analyze technical documents published by specialized organizations. The second step is a thorough analysis, including extraction, selection, and synthesis work of research materials. This aims to capture relevant information about OM phase for road infrastructure in particular. The third step is the ontology building. It aims to define concepts, properties, attributes, and relations between concepts. It is conducted according to a defined level of detail. And finally, an IFC standard extension will be proposed. As a result of literature review, the operation and maintenance information can be grouped in 3 levels. Each group contains information relevant to a project stakeholder role. All these information groups need to be integrated in operation and maintenance phase management system to enable an efficient system performance. These levels are first general information that are relevant to owner, public entities, observational rules, then project information that are relevant to observational rules and management rules, and finally management information that include function, operation, and condition information that are relevant to development, management, executive, procurement, and utilization rules. To highlight the research contribution, we use this figure. The black process presents nowadays approaches that are used to manage the operation maintenance phase in the context of BIM. These approaches enable a mapping between a BIM model and an existing system, like an asset management system, a database, or even a software, to retrieve information relevant to the operation and maintenance phase that are not supported by the BIM model. This process, although it is the most used, is intricate due to access problems and incompatibilities with the map system. It also needs recurrent adaptations over time due to software specifications change. The green process is what this research contribution suggests. It shows the IFC fault enrichment workflow and aims to manage the road operation and maintenance phase using only a BIM model. First, this will make operation and maintenance information available directly in the BIM standard data structure. Second, it will enable to retrieve operation and maintenance information from the BIM model to a map system, which will make it a direct database. Additionally, a hierarchy defined in BIM standard for object connection will permit complex analysis for better decision making. And finally, the respect of the future IFC road candidate schema will permit a fast integration of operation and maintenance information in the coming version of the IFC toward a whole lifecycle management for roads.
Sorry to interrupt, but you still have 2 minutes.
Sorry?
You still have 2 minutes.
Okay, thank you. For research progress, the IFC infra for OM ontology is established. The data model is developed, and this data model is implemented on a case study, which is a Moroccan highway segment, and a result will be published soon as a scientific paper. This is the end of my presentation. Thank you for your attention.
Thank you for your presentation. Now we're open for questions. You have 3 minutes for questions. Any questions?